Hello everyone, thanks for checking out my presentation. I titled this tentatively, How Similar Can They Be? A hydrological comparison of two physically similar watersheds in western Washington. So let's get started. So in the course of researching for this term project, I found these two watersheds that were both of similar size and had very similar data records, discharge data dating back from about the late 80s till present, and then water temperature dating from October 1st of 2007 to present as well. So I thought that was really interesting and hard to pass up in terms of doing some sort of analysis. Um, so I decided to stick with that. It's slightly different than my original proposal, which just didn't pan out because, big surprise, there wasn't a ton of data at the two locations that I initially selected the more that I looked into it. But both of these watersheds seem like they'll be a good stand-in, and so far have been pretty interesting. So yeah, they're about 26 linear miles apart, so very close to one another, and they're, as I said earlier, physically very similar to one another. They also have similar land use, except that the northern of the two, the northern more watershed of the two, appears to be logged quite extensively in the recent past. Just looking at some aerial maps, that's a subjective determination. And as I said earlier, they have similar data records. So the driving question became, how different or similar is the hydrology of these two watersheds? Considering what we have learned in class, can we reasonably explain the differences in their respective hydrology? And so after looking at doing the research and finding these two, it made me think of that assignment we had earlier in the semester, looking at the two neighboring watersheds and seeing how different they were. So the idea became to do a more extensive version of that and see if we could capture any differences or similarities. So I'll get into the watershed descriptions now, starting with the Cedar River headwaters and then moving on to the North Fork of the Tolt River. So looking now at the Cedar River headwaters, it's located just upstream of the Chester Morse Lake, which is a dammed reservoir that provides water storage as a drinking water source for City of Seattle and some of the surrounding municipalities. And the gauging station is located at roughly at river mile 43.5 approximately. The drainage area for the Cedar River Headwaters watershed is about 40.7 square miles, and it's made up of mountainous forest land that includes some previously logged areas based on some visual estimates. You can see some pretty straight lines on some of the mountain sides and some of the lower areas, so that's a subjective determination. There was some record of logging, but it wasn't too extensive from what I found so far. And so then the watershed itself is located approximately 8 miles southeast of Cedar Falls, Washington, in the western slopes of the Cascade Range. And Cedar Falls, Washington is just south and a little east of North Bend, Washington, along I-90. And ultimately the Cedar River discharges into Lake Washington at the very southern end of it. So some of you may be familiar with the Cedar River. And here's some basic watershed characteristics. Mean annual precipitation, according to StreamStats, is 117 inches of precipitation a year. The mean basin elevation was 3,300 feet, and a maximum basin elevation of 5,440 feet, and a minimum basin elevation of 1,500 feet, almost 1,600 feet. And the dominant hydrologic soil class is soil class B. And throughout the year, you can see the average temperatures here, which were taken from North Bend, Washington. That's the closest full climate data I could find. It was a little bit frustrating trying to track that down, but had to rely on U.S. climate data, which pulls their data from NOAA. But anyway, you can see typical temperatures you would expect in mountainous western Washington. At some of the lower areas. So maritime climate, so there's no huge swings between seasons and between day and night. It stays pretty regulated due to that being so close to the marine waters. And of course, the high temperatures are in the summertime, particularly in July and August. And then here's the average precipitation, again taken from North Bend, so it doesn't quite match up to our information from stream stats, but you can see the dry period is of course in the summer, which is to be expected. It sounds like there's many Washingtonians in here in this class, so you know what I'm talking about. So rainy from about October up until June, April, and my experience up into about July 4th. Summer begins July 5th, as they say. And so here, this is taken from USGS stream stats. This is just a delineation from the USGS stream gauge. And so this matched what the stream gauge said as well, 40.7 square miles. And as you can see, it's fairly mountainous through here. None of the peaks are too crazy, but certainly not flat terrain. And the general flow direction is west-northwest, discharging into Chester-Morse Lake, which then heads on off until Seattle, which you can see in this map here. Chester-Morse Lake, our basin, and then the Cedar River here, pardon me, as it discharges into Lake Washington. And so here's the hydrograph and some water temperature data reaching from October 1st of 2007 up until September 30th of 2016. So about 9 water years. Unfortunately, there's this about year's worth of water temperature data, missing from our graph. I couldn't find any explanation for that, but otherwise the water temperature data is pretty complete. There's only a few small gaps besides from this pretty large one. And temperatures in Celsius, and then discharges, of course, in cubic feet per second. And so you can see seasonal patterns that you'd expect. High flows in the springtime up until about mid-June. That's just a visual approximate. And the high discharge is usually associated with melting snowpack, as well as the pretty persistent rain throughout the season. So I'm sure there's some rain on snow mixed in there as well. And the water temperature data follows like an inverse relationship with stream discharges. You would probably expect low flows during the summer experience the highest water temperatures, and extreme low flows, like it relative to the data set, you can see the highest water temperatures, such as in this case. And it's too bad we don't have this as well, because it looks like it's pretty close to that. But anyway, the North Fork of the Tolt River, so the outlet that we used as like to delineate the basin and stream stats is roughly 11.7 river miles upstream of the confluence between the North Fork of the Tolt River and the Tolt River as it meets up with the South Fork. The drainage area is roughly 39.9 square miles, and again, it's in mountainous forestland, except that this area appears to have been logged fairly recently, per a subjective visual estimate, and a significant area looks like it had been disturbed during those events. So yeah, similar square miles overall, similar area overall. And it's located roughly 7.4 miles northeast of Carnation, Washington, which is a rural farming community east of Seattle. And that's in the western slopes of the Cascade Range as well. And it's a tributary, like I said earlier, to the Tolt River, which ultimately discharges into the larger Snoqualmie River, which is a pretty major river in the area. And so here's again some pretty basic watershed characteristics for the Tolt River, North Fork of the Tolt River, excuse me. So mean annual precipitation is almost 97 inches of precipitation a year. Mean basin elevation is about 2,600 feet, just a little over that. Maximum basin elevation is almost 6,000 feet, with a minimum base elevation of 665 feet. And the dominant hydrologic soil class is Class C. And similar to the Cedar River watershed, the climate data had to be pulled from a nearby town, the closest town that had significant climate data, which was Bering, Washington, which is located outside of the basin, just to the northeast, along Highway 2, near getting towards Stevens Pass, if you're familiar with the area. So again, you see the typical Western Washington climate per month and precipitation. The dry period is in the summer, with the rainy period mostly through the winter and early spring and in the mid to late fall. And here's the delineated basin per USGS stream stats. The overall flow direction is west-southwest before it discharges here into the Tolt River as it meets its confluence with the South Fork of the Tolt River. And it's north of the South Fork Tolt River Reservoir, which is another source of drinking water for the Seattle metropolitan area. So yeah, here is our basin, the North Fork of the Tolt River's basin. Here's where it discharges, the Tolt River discharges into the Snoqualmie River. And for reference, here is the other watershed, the Cedar River Headwaters watershed. So 26 linear miles apart, not too far apart, and in the same general area. And here's the same span of time. Here's a hydrograph for the same span of time, reaching from water years 2008 to water year 2016. There's a few decent gaps in the water temperature data, as you can see here, and there's a couple of other small data gaps which you probably just can't see at this resolution, but it generally follows the same pattern as the Cedar River. The significant amounts of discharge occur in the spring as snowpack melts, and rain events are kind of driving that and a part of that. And then high temperatures in the summer when the flows are at their lowest point. And so you can already see some similar patterns to the Cedar River, but if you hold on, I will show you the comparison between the two shortly. So just some general information. In Western Washington, the rainy season generally begins in the mid-fall and lasts until the mid to late spring. And I'll stop here because my time is about to run short. I'll meet you in part 2.